the next step is to add the 100-pound plate, and we'll do this on the left side. But first I need to figure out what is the local axis system. How am I going to know where to put that plate? The idea of this class is to build things in XYZ coordinates so that when the detail parts are merged into the assembly, they automatically land where they're supposed to be. So we'll create a new part. And we're going to try and build this 100-pound plate. So the 100-pound plate is 17.5 inches tall with a 2-inch diameter on the inside. So what I would do is first figure out where the local axis system is. So I'm going to just kind of open this up, make sure I've got my absolute axis, and I'm going to build a point in the geometrical set. That's why it's always defined, so you can build your wireframe before making your solid. I'm going to go to Essential, and I know point is in there, or that. I know this axis system is here, and I'm going to build the origin on the fly. So I'm going to right click and create that point. Here's what I know. It's 0 in X, 0 in Z, and a negative Y. So all you really have to do is figure out what is the Y value. Well, what is the Y value? The plate needs to go right up here against this collar. So it's going to slide on the sleeve and bump the collar. So where is the sleeve and the collar intersect? What point is that? You simply take half of this number, because I created this in the middle, okay, and we're going to go negative, whatever that distance is, plus 16.25 to come back. So how would I do this? Back to CATIA. For my Y value, I'll let the computer do the math. Okay, just for fun, I'll do this on my calculator first. I think it was 86.25 divided by 2 equals, so 43 inches would be all the way out here, but I need to slide it back 16.25. So take my calculator out. So 43 1/8 minus 16.25. It's 26,875. Now you could just type that in now that I know it, or what I do is I just do all that here. You can't do inches. You just got to do just the numbers, and it will translate to inches because my preferences are set to work in inches. Again, the 86.25. I don't remember. Do I even have that number? I was just making it up. It's 86.52. So 86.52 divided by 2 minus 16.25. So 86.52 divided by 2 minus 16.25. I'm just going to double check that. So 86.52 and then 16.25. So I hope you guys can see that. And that should have been a negative number because the directions say to put it on the left side. So I'll change that to negative and I'll hit preview. And I'll select OK. And that local axis is way off in no man's land. Remember my trick. When I create the axis, I immediately hide the absolute axis, go to view and fit all in. And now it's like I'm just working on a regular profile. I'm going to immediately rename this. Sorry. Forgot what I was doing just for a moment. To the local axis. Some people call it part axis. Whatever your company wants to call it, it's fine. But it's just the new index for where my plate's going to be. So the plate is going to be flush on the XZ plane. So I'm going to select this and create a sketch on that plane. And then I'm simply going to go to sketch and create that circle right from the center out, and then I'll create another circle right from the center out. And I'm just going to highlight this whole thing and auto constrain it. When it comes to circles, it's easy for me to remove them from the axis, so I can just simply hit auto constrain and I don't need to set up data or nothing, just let the computer figure it out all from the center. I'll edit this and I'm going to change this to the diameter because I was given a diameter. The diameter given was 17.5, I believe, so 17.5, and then also down here under the descriptions, the 2-inch center hole, and then this plate being 17.5 inches in diameter. So this can be huge. 17.5. Double click this, change that to a diameter, and then 2-inch diameter, fit all in. It is a closed profile of 2 circles, and it is constrained. All I have to do now is exit out and build the plate. Which direction should I go, in the positive Y or the negative Y? I'm going to use a pad. Oh no, I created that where it shouldn't be. Remember, when you make your solid, the part body should always be the in-work object, and if you're making a sketch for that solid, that should be in the in-work object as well. I believe it said it was 2 inches thick. So this plate is also 2 inches thick. So preview that, and it appears to be going in the Y direction. So I'm going to inverse the direction. Preview that, because I want this face to touch the sleeve, because my local axis for this plate is built right here where the collar and the sleeve touch. Okay, so I got to be building everything in the negative direction when I do this plate over here. Whoops. So that plate again was 100 pounds, 17.5 inches, 2 inches thick. So I'll select OK to this plate. Always go to View and Fit All In, or ISO View and Fit All In before you leave. It should always be saved in this orientation. Okay, so you have the barbell, we have the plate. I'm going to hit the plus to create a new part, which will be an assembly. When I bring in, or when I open up an assembly, I want to bring the details into this by inserting existing parts. So we're going to do an insert existing product. On an older version, it was just simple insert existing part. Now it's insert existing product. It's going to come up with this. We're going to let it know we're doing more than one by hitting multiple. Select on this one, select on this one. I don't know why, it doesn't matter, but I like to start with this one first. If I was smart, I would have renamed this to barbell. Come over here and select this. If I was smart, I would have named this 100-pound plate. And then hit the green check mark to let it know I've grabbed all my details. And you can see it looks like I got it pretty close. We'll see if I'm on the money or not. I'll check that by going to Tools, guess I gotta grab that gray bar and slide this over. I'm looking for, oh God, where is it? I'm looking for the clash features. I've got to be in the right tab first. Got to be in the assembly tab, and I'm looking for the feature called interference check. So I'm going to do an interference check. And I want to go to specifications and make sure I got contact checked. I'm hoping that these two parts are in contact. So when I say OK, I got a contact situation. When I click on this, it's letting me know that this part and this part are touching each other. They're in contact. So as you add in all your plates, make sure to check to make sure each plate is contacting. I like to do them as I'm inserting, but honestly, I sometimes get lazy, just throw them all in there and then see what it comes up with. It should work fine either way. Now, what's goofy here is we should name this, okay? So just to make this clear, I'm gonna come back to here and I'm gonna right click the top one and go to properties and rename this to the barbell. Make sure you find the appropriate tab, which is reference in this case, and we'll type in barbell. And then when I click over here, properties, highlight this and go 100-pound plate. When I come over to the assembly, you see they're renamed automatically. Then I know which is which. It makes it a lot easier for me to tell what's going on. Now, if it were a part number, what you would do is over here, I would come over here, properties, copy that, and then come over here, properties, and call it barbell. Okay, and then I'm going to go back here to this property because I forgot to name it. Just for this example, just to say we called it the 217 ET XXX-100. Hit enter. When I come over here, I make this tree a little bit bigger. Okay, so I have that, and then when I come back to this, the part number here, I know it's the barbell. So it's nice to have the nomenclature when I'm bouncing back and forth. This one's barbell, and this one here, I'm going to name this one different. I'm going to go right here, go to properties, I'm going to take this, I'm going to copy it. So I just hit Control C or right click and hit copy. And then I'm going to name this one, actually I should have named the other one something else. I'm going to call this the 100 and say OK. And I'm going to go to right click here and go to properties. And I'm going to paste that answer in there, or some of you are fast, you can just type it over. Oh, what? I thought I copied it. 100 plate, all caps. Again, it's nice just to see them there. I'll come over here. I'm going to change this to the -10. All right. So when I go to my assembly, I see my part numbers. But one thing about this is the part numbers, if you're not very intimate with it, it's nice to know, well, what part number is that? Which one is which? Like I can tell when I hover over it, but it's nice just to see it in the list. So what I'm going to recommend you do is go to Properties, Instance, and this is the barbell. Right click on this and go to Properties. And we're under the Reference tab. No, the Instance tab. Make sure you go to the Instance tab to do this. We don't want to change this name. We want to change the instance. And I'll change this to 100-pound plate. And then everyone knows what those parts are. It's just nice to see the nomenclature for that. Your challenge is now to identify all the local axes and add a plate on each side for the 45, 35, 25, 10, 5, and 2.5 pound plate on each side. Work as a group. Everybody pick a plate and then merge the plate into the assembly and see how it works. And then when you've done that, I'm going to challenge you on this side is to try and build it in the assembly instead of merging in the assembly. Create a part in the assembly, create the local axis in the assembly, build the plate in that assembly. Do not duplicate this and mirror it over there. I want you to practice two techniques, merging them from different details and building details inside an assembly. All right, that is your challenge. That's your startup for this module. Hopefully you have fun with it and helps you understand how to create a local axis system to build a part in its true XYZ coordinates.